Hi guys, today we're going to learn more about graphing rational functions. So in the first example we have y is equal to 3x squared minus 6x divided by x minus 2x plus 1 squared. So the first thing that you always need to do is you need to make sure that you factor, okay? So I take the greatest common factor here and I clearly see that it's 3x. So you have that this one is going to be x and this one is going to be a negative 2. Okay, after that I have the x minus 2, the x plus 1 square here. Okay, then I immediately recognize that I can cancel out the x minus 2 here. So you simplify it a little bit more, so you have 3x divided by x plus 1 square. Therefore you can realize that you have a whole. Okay, so if you have a whole, you know that the whole is going to be when you set x minus 2 equals 0. So you know that the whole is going to be at x equals 2. So I have the x of the whole, but I also need the y. So how are you going to find the y? Well, you plug it here, so you have that your whole is 2, 3 times 2 divided by 2 plus 1 square. So this is a 6. This one is going to be 3 squared, so you have that one is going to be, I'm going to rewrite it here so you know that it's going to be 6 divided by 9, which you can easily simplify this as 2 over 3. Okay, so that's our whole. The second thing that we're going to find here are the horizontal asymptotes, or maybe just one. Okay, so I set my denominator equal to 0, so I have this equal to 0. Please note that here your asymptote, you recognize that this asymptote, negative 1, is going to be multiplicity 2. So that's going to be kind of important, okay, when we graph. Okay, so I'm going to let that multiplicity there too. Okay, after that we know, and that one is the vertical, I don't know why I put h, okay, so that one is the vertical asymptote. The horizontal asymptote, we already talked in class that you need to analyze the degree of the numerator and denominator. The degree of this one is 2, the degree of this one is 3, because this one is 2 and this one is 1. So we have that it's big on bottom. Okay, so when we have big on bottom, we know that the asymptote y equals 0 is going to be your horizontal asymptote. Okay, so please remember, big on bottom, then the 0 is going to be your asymptote, y equals 0. Okay, so we have our horizontal asymptote. The next thing that we need to ask ourselves, does this graph crosses the horizontal asymptote? So that's the question here. What are you going to do? You are going to set whatever the value of the asymptote you have, which in this case is 0. You set your equation equal to 0. Okay, as we mentioned in class, okay, I honestly don't put this part. Why? Because I'm going to pass it multiplying times the 0, so I have 0 equals 3x. So you know that this happens at x equals 0, so this is a yes, and I know that x0, y0 is going to be where my asymptote crosses. Okay, so I already know that. The next thing that I'm going to find here is the x-intercept. I know that the x-intercept happens when I set my y equals 0. Similarly to the horizontal asymptote, in this case you're going to set 0 equal to your equation, which you only need to set the top to 0, so you have x is equal to 0, and clearly you have that the x-intercept is this one. In the same way, you are going to tell me, so do I really need to find the y-intercept? Well, you already know that the y-intercept is going to be 0. Why? Because you have this, so you have y is going to be equal to 3 times 0, which you already know that it's 0, divided by 0 plus 1 squared. So you know that this is 0 divided by 1, which you know that it's 0. Boom, again we have the 0, 0. Okay, so that's what we have for this part. Okay, now here comes the interesting part. Now we are going to obviously graph everything. Okay, so I would start with the asymptotes. Okay, so you have an asymptote at x equals negative 1, meaning over here you have your beautiful asymptote. Okay, so that one is my asymptote. Okay, let me put it there so you can see it. So you have that it's x equals negative 1. Your horizontal asymptote is at 0, so as you know, I just do it here so you can clearly see it. Okay, so y equals 0. Okay, so now we're going to start graphing. So we have the 0, 0, which is here, and then another 0, 0, and then we have the whole here. Okay, so the whole is going to be at 2 and 2 over 3, somewhere there. Okay, so I start graphing this, and I start like this. I cross my asymptote, then I move on here, and then I'm going back next to the asymptote. Okay, after that I recognize that this arrow is going to negative infinity, so since the multiplicity of this guy is 2, this arrow that comes from the other side is going to be also coming from negative infinity. Okay, because it's even. Okay, because you know that it's 2. So your graph here, you can just sketch it without using the calculator, of course, and you have something like this. Okay, and that's pretty much for number 1. For number 2, what we have is we can realize that at the top you can take out the greatest common factor, so it's 2, so you have x squared plus x minus 20, and then you divide this by the already factored out situation that you have over here. Okay, so obviously we can factor the numerator a little bit more. Okay, so I would obviously factor at x plus 5, okay, x minus 4, okay, and then you have here your denominator that I forgot the, okay, plus 3. Okay, so after that, let me do the lines, that otherwise it looks horrendous. Okay, so you have that. Okay, you realize that I have a whole. Okay, so I have the 2 times x minus 4 times x minus 3 x plus 3. Okay, so we have that. Now what's the next step? I'm going to set my whole. My whole, it was x plus 5 equals 0. Therefore, you know that your whole is going to be at x equals negative 5. Okay, since you have the whole at negative 5, what you're going to do here is you're going to plug 5 into your equation here. Okay, so you have that it's going to be negative 5 minus 3 times negative 5 plus 3. Okay, so you have that situation. Okay, I'm going to put it here, negative 5, and then this one is going to be that's going to be, let me rewrite it here because I think we're going to simplify it a little bit more. So we have negative 9 times 2 is going to be negative 18, and then here you have negative 8 times negative 2, that's 16. Okay, so we have that, and we can simplify it a little bit more, dividing it by 2, so you have that it's negative 9 over 8. Okay, and that's your whole. The next thing that we need to find here is the vertical asymptote. For the vertical asymptote, you need to set your denominator, already factor out and cancel, to 0, so you have x minus 3 x plus 3 equals 0, so you know that when we solve, you have that x is going to be equal to plus minus 3. So you can go ahead and put here your 2 beautiful asymptotes, okay, vertical asymptotes. For the horizontal asymptote, you know that you have degree 2 and this is degree 3. So we have big on bottom, okay, so big on bottom. Again, we have a bubble situation, y equals 0, so y equals 0 is going to be your horizontal asymptote again. Now the question is, does it cross the horizontal asymptote? And okay, so we can see 0 is going to be equal, and I would just set to the numerator. You know that that 2 is meaningless because we can divide by 2 and that's it. So you have x equals 4. Okay, so x equals 4 is a feasible solution for the asymptote, so actually yes. Where it crosses the asymptote, you know that it's going to be at 4, comma, and then plug the 4 here. If you plug the 4 there, clearly that's a 0, okay, because when you plug it here, 2 times 0 and whatever in the denominator. So you know that this one is going to be a yes, and specifically is going to be at 4, 0. Okay, the next one that we need to find is the x-intercept. For the x-intercept, remember we let the y equal 0. So you have 0 is going to be equal to 2 times x minus 4. Pretty similar to the previous one, so you already know that it crosses the horizontal asymptote at the same point that it crosses the x-intercept in this situation. Okay, that's not always the case, but that's a coincidence here. Okay, so for the y-intercept, what we have here is we let our x be equal to 0. Okay, so after that we know that y is going to be equal to 2 times 0 minus 4, because I'm plugging the 0 here. Okay, divided by 0 minus 3 times 0 plus 3. So this is going to be negative 4 times 2 is going to be negative 8, divided by negative 3 times 3 is going to be negative 9. So we go ahead, and you know that your y-intercept is going to be at the beautiful point 0, 8 over 9. Okay, so we have all our information now. We can start graphing. Okay, so let's start graphing my asymptotes. Okay, so I start with my vertical asymptote, so I know that it's at 3, so let me see it here. Okay, and then 1, 2, 3. Okay, so we have it here. Okay, so we have it x equals 3 and x equals negative 3. Okay, so those are your two vertical asymptotes. Now let's move on to the horizontal. Okay, so the horizontal we have here, okay, y equals 0. Okay, so we have all our asymptotes. Now let's graph the points. Okay, so the first point that you have is 1, 2, 3, 4. Over here 0. Okay, so that's a x-intercept slash crossing the horizontal asymptote. Please remember that I'm doing this dashed so you can see it in the video and everywhere. Okay, the y-intercept, you know that it's going to be 0, 8, 9, so it's going to be somewhere here. Okay, then crossing this one. Okay, we already put that one, and then the whole is going to be at negative 5, 1, 2, 3, 4, 5, and then negative 9 over 8, so a little bit over 1. Okay, so it's there. Okay, so you're going to be like, oh my goodness, where I can start? Honestly, I would start with this part. Okay, clearly you are not crossing any of the asymptotes for obvious reasons. Okay, you never cross a vertical one, in case that you were wondering. So I'm going to have this here, and then this one is going to follow the shape of my asymptote. Please remember that your end behaviors, they always need to be very close to the asymptote, because that's what they are approaching. Okay, on this piece, okay, so as you can see, we are going to have one piece here, then we're going to have another piece here, and then the last piece is going to be over here. Okay, we have a point here. Okay, clearly we're not crossing the horizontal asymptote because we don't have that information here. Therefore, since the multiplicity of the x equals negative 3 is 1, this one starts from negative infinity. It goes to negative infinity, excuse me. So this one will start from positive infinity, opposite. Okay, so it will arrive to that point. Okay, and since it cannot cross the horizontal asymptote, then it's going to return to positive infinity. Okay, here. Okay, and remember, it needs to be very close to the asymptote because that's what it's approaching. Okay, so after that you analyze this asymptote, x equals 3. The multiplicity of this asymptote is 1. Therefore, this arrow will be opposite. Okay, the arrow here, it would be opposite to this one, so you know that we are starting like this. Okay, after that you know that you are going to cross your horizontal asymptote, so it's pretty clear that this is going to be the behavior that your function is getting. After that you cross slightly the horizontal asymptote, and after that you need to go back to your horizontal asymptote, because the horizontal asymptote tells you the end behavior, and that's why we keep the function very close to the horizontal asymptote there, and that's it. Okay, so for number 3, you have y equals x squared minus 4 divided by x plus 3. So what we're going to do here, obviously, is going to be factoring the top. Okay, so you have this equation, and you have x plus 3 here. Really nice. Okay, so you're like, oh, I don't have holes. Yeah, you don't. Okay, you can immediately see that you don't have any holes. Okay, but that's fine. Okay, so we don't have holes, so if you have this, well, what are you going to do? Well, you're going to write none. Okay, so after that you're going to be like, okay, no holes, let's start with the rest. Okay, so the rest is going to be start with your vertical asymptote. Okay, so you're going to set your denominator equal to 0 having this, so obviously you know that it's x equals negative 3. So x equals negative 3. Please note that that one has multiplicity 1. After that, you have the horizontal asymptote. The horizontal asymptote, you recognize that this is degree 2, this is degree 1, so we have big on top. If we have big on top, is none. Okay, so we have that it's none. Okay, but if we don't have horizontal asymptote, we learned the other day that you might have a slant asymptote, and in this case it's what happens. Okay, so you have slant asymptote. What are we going to do when we do slant asymptotes? Well, you are going to do long division. Okay, so let's recall the long division. You have x squared plus 0x minus 4, and this is going to be divided by your beautiful number x plus 3. Okay, so, and you're like, where are you getting this? Okay, the x plus 3 is the denominator. Okay, and this expression is your original. Okay, so I'm going to long divide this. Okay, so I know that to make this x and x squared, I know that I need an x. X times x is x squared. Positive outside comes negative inside. X times 3, it's going to be 3x positive, but when it goes inside, it goes negative. Okay, so I have this. I cancel this. 0 minus 3 is negative 3x, and then I drop my negative 4. So you have this equation. Now what do you have? You look at your leading coefficient, which is negative 3x, and you compare it to this one, and clearly you need the negative 3. Okay, so you have the negative 3 times x is going to be negative 3x outside comes positive inside. Negative 3 times negative 3 is negative 9. Negative 9 outside comes positive inside. I cancel this. I have my remainder this. And you're going to tell me, so what do you need for the slant asymptote? Actually, I need this. Okay, I don't even care about the remainder. Okay, so you have that y equals x minus 3 is going to be your slant asymptote. Okay, you're going to tell me, so it's an equation? Yes, it's a linear equation. Okay, it's basically this asymptote is a diagonal asymptote. Very beautiful. Okay, so let's move on with the rest. So that's how you can find the slant asymptote, and this happens when you don't have horizontal asymptote. If you do have horizontal asymptote, there's no slant asymptote. Okay, it's either or for the horizontal and slant. Okay, so let's move on to the x-intercept. What are we going to do for the x-intercept? You know that I'm going to set my y to be equal to 0. So having that, I have my numerator. Okay, so I'm going to make my life easier and just to put the numerator and set it to 0, because I know that the denominator will pass multiplying the 0, and that's it, right? So you have that x is going to be equal to plus minus 2. Okay, so pretty neat. You know that your x-intercepts are going to be this 2. Okay, after that you need to find your beautiful y-intercept. Okay, set x equals 0. Okay, so you know that when that happens, you have that y is going to be equal, and plug that one here. Okay, so you have that it's going to be 0 minus 2 times 0 plus 2 divided by 0 plus 3, which clearly you know that this is going to be negative 4 over 3. Okay, so you know that your y-intercept is going to be the point 0, negative 4 over 3. Okay, so we have all our information. Let's graph our asymptotes. Okay, so you have that x is equal to negative 3. Okay, so that's going to be your vertical asymptote. So let's do it here. X equals negative 3. After that, how in the world we're going to find this one? Well, you're going to graph it exactly like you were doing this in Algebra 1. I would set the intercepts. Okay, so you know that when x is 0, I have that my y is going to be 3, so 1, 2, 3. Okay, and then when my y is 0, my x is going to be positive 3, so 1, 2, 3. Okay, with that you have more than enough points to and a ruler. Okay, so you have that your slant asymptote is going to be this beautiful line. Okay, so you have that is your slant asymptote. Okay, I'll label it in case that you are wondering what's that. You know that it's that. Okay, next thing. Okay, graph the points. Okay, so we have a lot of information, which I love because I can make a better graph when I have so much information. Okay, so we have -2, 1, 2, 0. Okay, so that's one of my intersects. Then I have 1, 2, and 0. Okay, so that's your second intersect. Okay, then we have 0, -4/3. Okay, so it's going to be a little bit below the -1. You have it there. Look at that. Okay. And then what else? You have more information? Not really. Okay, so I have something, remember, something that looks like this. Okay, and remember, go close to the asymptote. That's why the asymptote is there. Okay, so we have that chunk, and you are going to tell me that's it. Well, no. Okay, remember, you have a vertical asymptote, so you already have the right side of this vertical asymptote. Now we need the left side. Where is that left side of the asymptote? Well, you have two options. It's either above your slant asymptote or below. Okay, so let's analyze this vertical asymptote. You know that this vertical asymptote, the multiplicity is 1. Therefore, if this arrow starts from positive infinity, the opposite one is going to start from negative infinity because it's multiplicity 1. So you already know, you don't need to be super specific, that your piece is going to be here. And with that, you have enough. Okay, I didn't need my calculator, so that's pretty cool. Now for number 4, again, we need to take the greatest common factor from the top, and you have that this is going to be equal to x squared times x plus 5, okay, which is pretty nicely factored. And then the denominator, we know that we can factor it as what? X plus 5, x plus 2. Okay, so we have this situation, and you can see that I'm about to cancel that. So you have a very user-friendly equation, x squared divided by x plus 2. Okay, so the first thing, before I forget, I need to mention the whole. Okay, so the whole, you know that it's going to be x plus 5. You equalize it to 0. You have that x equals -5 is going to be the x of your whole. Okay, so then we have the y. Where are we going to find the y? We are going to plug it here. Okay, so you know that it's going to be -5, comma, and it's going to be -5 squared divided by -5 plus 2. With this, you know that this is going to be equal to -5 comma 25 divided by -3. Okay, so we just, that one you cannot simplify it, so I just copy that one here. Okay, after that we start traditional stuff and things. Vertical asymptote, you know that it's x plus 2 equals 0, aka x equals -2. Okay, so you are like x equals -2. Please note that the multiplicity is 1. The horizontal asymptote, you recognize that it's big on top because this is degree 3 and this is degree 2, so big on top, none. Okay, so you have a situation where you don't have the horizontal asymptote, but you do have a slant. Okay, so you do have a slant asymptote. Okay, when we have a slant asymptote, please note that this is quadratic and this is cubic. So I have, let me write my cubic equation here. X cubed plus 5x squared plus 0x plus 0. Okay, remember to replace the spaces. More than anything, you need to save the spaces there. Okay, so you have that, and then outside we have that it's x squared plus 7x plus 10. Okay, so what we're going to do is you need to make sure that this term becomes this x cubed, so you need an x times x squared, it's going to be x cubed, positive outside comes negative inside, x times 7x is going to be positive outside is positive 7x squared, comes negative inside, x times 10 is going to be 10x, positive outside goes negative inside, so you cancel. Let me put a line here so you can see it. Okay, so you cancel, you have that this is -2x and this one is -10x, drop the 0, so you have this. Okay, now what, you compare your leading coefficients here and here, so clearly you need the -2, so you have the -2, and actually I can stop here, dot dot dot. I know that I'm going to have my remainder, but since I have the same degree, I know that the next step is going to be my remainder, so I know that this is my slant asymptote. So we have y equals what was it, x minus 2 is going to be your slant asymptote. Okay, so this one is your slant asymptote. Okay, I'm just going to leave the dot 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 there so you know what to do. Okay, after that we have that it's going to be the x-intercept. The x-intercept is when y equals 0, so you know that that is going to be 0 equals x squared, which you know that it's x equals 0, which you know that it's the point 0 0. So you might ask me, hey, I know that the y-intercept is going to be 0 0. Do you have me need to show my work for that one? If you want, but I already know that with this is enough, right? So because you know that y is going to be equal to 0 divided by 2, so this is 0. Okay, so that's what I have. Okay, so now let's graph our information again. So I start with my vertical. Okay, so I only have one vertical asymptote, so I have this, and then my horizontal one I don't have, but I do have a slant. Okay, the slant is going to be 0, -2 on this one. Okay, so you have your diagonal there. Okay, let me just make sure that it's correctly positioned. Okay, so my slant asymptote. Okay, so you have your slant asymptote. Let me, y equals x minus 2, and the vertical asymptote is going to be x equals -2. Okay, so we have that piece of information. Look how beautiful it looks. Okay, next thing, 0 0 is going to be an x and y intercept. Okay, after that, none. Okay, so we have a hole here, so we have 1 2 3 4 5, and then this one is -8 point whatever, so we have 1 2 3 4 5. Okay, so the hole is going to be somewhere here. Okay, I'm making it big so you can see it. So clearly you have that your graph. Look at this. Okay, it comes from the asymptote here. Okay, close to the asymptote. Remember, that is the key. You want it close to the asymptote. Okay, so this one you can just kind of like, you know, start it from the asymptote. You know that it starts opposite because what's up with this one? The multiplicity is 1, so you're like, oh, okay. So I know that it's going to be something like this, and then you just follow your asymptote here, your slant asymptote, and you have that situation. Wasn't that nice? And that's your graph.